Hello, everybody. Today we're beginning our pathogenicity unit. Over the next several lectures, we're going to follow a pathogen from the moment it first comes into contact with a host all the way through causing disease. Today, we're focusing on the very first step, encounter. Before a pathogen can invade, produce toxins, or evade the immune system, it first has to find a way to reach the host. By the end of this module, you should be able to describe the major routes by which pathogens encounter hosts. We're just going to give you like 3 examples, but there are more in the book that you can check out as well. When we think about infection, we usually think about it from the host perspective. We are exposed to a microbe, the organism colonizes, disease develops, and eventually we can recover. From our perspective, infection appears to be a relatively simple process. However, from the pathogen's perspective, causing disease is actually a series of challenges that must be overcome. First, the pathogen must encounter a host. If it never reaches a suitable host, infection cannot occur. Next comes adhesion. The pathogen must attach to host tissues and avoid being removed by mechanisms such as mucus, urine flow, tears, or saliva. After attachment, some pathogens invade host tissues. This may involve entering host cells, crossing epithelial barriers, or spreading deeper into the body. The pathogen must then survive host immune defenses, including phagocytosis, complement proteins, and antibodies. They're all constantly attempting to eliminate the invading microbes. If the pathogen survives, it can begin causing damage through toxin production, tissue destruction, nutrient theft, or by triggering harmful immune response. Finally, successful pathogens must achieve transmission, allowing them to spread to a new host and continue their life cycle. Over the next several lectures, we will follow pathogens through each of these stages. Today, we begin with the very first challenge, encounter. For infection to occur, a pathogen must first encounter a host. Different pathogens have evolved different strategies for accomplishing this. Neisseria gonorrhea, the causative agent of gonorrhea, is typically transmitted through sexual contact. Uh, Mycobacterium tuberculosis and Streptococcus pyogenes are spread through inhalation of respiratory droplets. E. coli, uropathogenic E. coli at least, often reaches the urinary tract through fecal contamination, or actually whatever it's causing a disease in. When you have an E. coli infection, it's usually from fecal contamination. One important pattern you'll notice throughout this course is that the route of encounter often determines where infection occurs. A pathogen can only infect tissues that it is able to reach. So let's look at a specific example. Here we have uropathogenic E. coli, or UPEC, the most common cause of urinary tract infections. Unlike many pathogens that are acquired from other people, UPEC is often already part of the patient's normal intestinal microbiota. Infection begins when bacteria from the gastrointestinal tract gain access to the urethra. This can occur through fecal contamination, certain hygiene practices, sexual activity, or catheterization. Once a bacteria reaches the urinary tract, they have successfully completed the encounter stage. Their next challenge is avoiding removal by urine flow and establishing a foothold in the urinary tract. Neisseria gonorrhea provides a different example of pathogen encounter. Unlike UPEC, which often originates from a person's own microbiota, gonorrhea is typically transmitted from an infected individual through sexual contact. During transmission, the bacteria move directly from one person's mucosal surface to another. Because of this route of transmission, infections are most commonly found in the urethra, cervix, rectum, pharynx, or conjunctiva, which is the eye. This illustrates an important concept in pathogenesis. The route by which a pathogen encounters the host often determines the tissues that become infected and the disease that develops. Streptococcus pyogenes can encounter hosts through multiple routes of transmission. It is commonly spread through respiratory droplets released when infected individuals cough, sneeze, or speak, making it a frequent cause of strep throat. However, strep pyogenes can also be transmitted through direct contact with infected skin lesions, leading to diseases such as impetigo. Because it can spread through both respiratory and skin contact routes, this organism is capable of causing a wide variety of infections. This highlights how a single pathogen may use multiple transmission strategies to reach different tissues within that host. So, In this lecture, we examine the first stage of pathogenesis, encounter. Before a pathogen can adhere to tissues, invade the body, or cause disease, it must first reach a suitable host. We saw that pathogens use a variety of transmission routes, including direct contact, contaminated surfaces, respiratory droplets, contaminated food or water. Some of these we didn't particularly talk about, but they also exist. So you can have vectors that transmit disease, and sometimes medical procedures can introduce these diseases. We also examined several examples, including UPEC, Neisseria gonorrhea, and Streptococcus pyogenes, and saw how they, specifically, their route of encounter often influence the tissues that become infected and the disease that develops. In our next lecture, we'll move to the next challenge pathogens face, which is adhesion. Once a pathogen reaches host tissue, how does it avoid being removed and establish a successful infection?